equilibrium and KEQ expressions and how to write them. So let's start with our generic equation. Now this is a generic equation for any reversible chemical reaction. Now you learned in your notes that equilibrium is hit when the rate at which these become this equals the rate at which these become this. The forward reaction rate equals the reverse reaction rate. Now, a big misconception that students sometimes have about equilibrium is they think that equilibrium means that there's equal amounts of products and reactants. And no, there's not equal amounts. The concentrations will not necessarily be the same. Actually, usually they're not the same. It just means that the rates of the forward and the reverse reaction are the same. So at that point, the concentrations are no longer changing. To us, it would seem like there's not a reaction happening at all, because to us it would look like nothing was changing. But in reality, both the forward and reverse reaction would be going on. Now that is what you talked about in your notes today. Now I want to talk to you about how to write a KEQ expression. So the way you do it is you take your amounts, and products are going to be on top, reactants are going to be on bottom. Do you remember what brackets mean? We saw it in the acid-base unit. Brackets mean molar concentration of. So it's the molarity of this substance. Now this is your coefficient. And you take your coefficient and you turn it into an exponent. So put the products over the reactants, and that's going to be your KEQ. This is a constant that gives us a good idea of a ratio between the products to the reactants. So let's go ahead and get started, but before we do, I want to remind you of something else you saw. When you're writing KEQs, it is very important that you ignore solids and liquids. That's probably the biggest mistake that students make. They don't ignore the solids and liquids. So actually when I write my KEQ expressions, I cross off my solids and liquids before I even start. And that reminds me to not include them in the KEQ. So we're going to practice writing some of these expressions, and then we're going to get some practice actually understanding what K means. So let's get to work. Here's the first reaction. So notice the first thing you should check is the states of matter. We've got two gases. Gases are included. Gases and aqueous are included, so we are going to put both of these substances in our KEQ. It's going to be the concentration of products over the concentration of the reactants. So on top, we're going to put the concentration of our first product, exponent for the coefficient, divided by concentration of the reactant. And there you have it. You have done your first equilibrium expression. Woohoo! Let's do another one. Now look at this one. Gas, 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 gas. All four of those should be included in our KEQ. So our equilibrium expression equals concentration of our products times the concentration of our other product. Now remember, the brackets mean concentration of, divided by concentration of our reactants. Bracket CO times bracket H2. Do you remember what we do with that 3? Yep, we turn it into an exponent to the third. So these aren't too bad. Let's look at this one. Before you do anything, you need to cross off all solids and liquids. So there is a solid. We did not include it at all. So KEQ, in this case, would equal Ca. Now, you have to leave the charge. So write everything the same. Don't change anything about it. And then put the OH in the second bracket. But then we need to turn the coefficient into an exponent, squared. And I actually don't have any reactants here, so I could have written this a little bit lower and just said that the KEQ equals the concentration of calcium times the concentration of hydroxide squared. It's actually like divided by 1. You don't have to actually put that there. There it is. Let's do this next one. On this one, we look through, we cross off all solids, or liquids. In this case, we've got some solids. So cross those off. And this is the only one that's affecting the KEQ. So our equilibrium expression only has to do with that CO2. And last one, we cross off solids and liquids. Now we don't have anything on the product side. So to get our KEQ, we put nothing on the top part. So how are we supposed to do that? Anytime you don't have a product that is a gas or aqueous, you put a 1 on top, and then we're going to put these on the bottom. Concentration of H2, and that exponent, the coefficient turns into an exponent, squared, times the concentration of O2. So what does this all mean? And really what it is it's a ratio of the concentrations of the products over the concentrations of the reactants. So this is not what the KEQ is, but this is kind of like the simplest way to understand it. KEQ is basically more complicated than this, but very basically the concentration of the products over the concentration of the reactants. Because remember, I told you that the concentrations are not always the same. So because of that, the K gives us an idea which reaction is favored. If there's more products, that means that the forward reaction is favored because there's more of these. If there's more reactants, that means the reverse reaction is favored because there's more of these. Remember, the rates are the same at equilibrium, and you can only write KEQ expressions. The K will be the case. It'll be a constant for any equation, and it'll be the case when the reaction is at equilibrium. That means equal rates, equal rates. So let's talk about what this KEQ actually means. So if I gave you a KEQ value, you would need to tell me what is going on. If the KEQ is larger than 1, bigger than 1, that means that the top is bigger than the bottom. That means that there are more products. Than reactants. If KEQ is less than 1, that means that there's more reactants than products. That means that the reverse reaction is favored. If KEQ actually equals 1, which is not very common, you don't see it very often at all, but if KEQ was exactly 1, that means that the concentration of products equals the concentration of reactants. Basically, remember it's a little bit more complicated than that, but basically the products and reactants would equal. This is the only time when KEQ equals 1 is the only time that we have equal concentrations on both sides. Not very common at all. So, products equal reactants. So I've got one more question here, and you saw this in your notes, but I wanted to emphasize it in my video as well. What changes K? I told you K is a constant for any reversible reaction at equilibrium, equal rates. So what changes K? There are certain things you can change to this. I could change concentration of certain substances, I could change the pressure, I could change the temperature. K is going to stay constant unless you change one thing. That's it, just one thing. What changes K? Temperature. That is it. Everything else would still cause K to stay the same. So if I change the concentration of water gas, water vapor, it would ultimately switch and move around in order to keep K constant. And that's actually how it moves around and how it switches is Le Chatelier's principle, and that's the next topic we're going to be talking about probably tomorrow. But temperature is the only thing that actually changes this numerical value. It's very important that you know that. So before I end this video, I want to go over some key points. Generally speaking, you're looking at products over reactants. You are taking the coefficients, turning them into exponents. Do not change the substance at all inside the brackets. Ignore all solids and liquids. And make sure that you review and know generally what K actually means. If it's greater than 1, less than 1, or equals 1, what that actually looks like. And then make sure you know that temperature is the only thing that can actually change K. Thanks for watching.